All right, so today we're going to take a quick look at the relationship between ratios, fractions, percentages, decimals. They're all kind of like the same concept but expressed in different ways. And I think we can understand how to sort of switch between them and understand those different forms. I think we can get off to a really good start with some of this stuff. So let's start with, like, in my opinion, the simplest fraction that you can have, which is 1/2, right? So if I was going to take this circle and I was going to divide it in two, and I'm going to shade 1/2 and leave the other half blank. So the first thing that's really apparent to my eye, to me anyways, is the kind of ratio that I have these two equal parts to my circle, and one is shaded and one isn't. And so for me, it's pretty easy to see that as a 1-to-1 ratio. There's one thing that's different, there's one thing that's different, 1-to-1. So the first thing we want to do then to transfer that to a fraction, right? To a fraction is think, okay, well, 1 plus 1, there's two parts. That means there's a total of two parts. That's my denominator. And that if I'm thinking of a percentage, I'm going to think of the percentage that is shaded. So one of those two parts is shaded. So that gives us 1/2. So there's our fractions. We went from a picture to a ratio to a fraction. Okay. Now, sometimes we want to go from a fraction to a decimal because that's a really easy way to get it to a percentage. So a really easy way to do that is I take my denominator, right, and I put it here, and I take my numerator and I put it in the bracket here, or in the, under the division sign here, right? And this is 1 divided by 2, 1 divided by 2. So even though it looks pretty simple, let's do our long division. Well, 2 doesn't go into 1, so I have to add a 0, which means I add a decimal. 2 goes into 10 5 times. Therefore, 1/2 as a decimal is 0.5. Okay. Now, this is a much easier number that'll help me see a percentage. And the way to get to a percentage is to take my decimal and I multiply it by 100 and I add a percent sign. So 0.5 times 100, well, anytime I'm multiplying by a number that starts with 1 and ends in 0, I count the number of zeros. There's 2 zeros. So I move my decimal place 2 to the right because I'm multiplying, right? So moving my decimal places 2 to the right yields 50, and I add my percent. So that's 50%. So again, we've got our visual representation here. We've got our ratio, right? We've got our fraction. We've learned how to convert a fraction into a decimal and how to convert a decimal into a percent. Well, let's say I want to go backwards. For example, 50%, I want to make that a decimal. Well, if I multiplied a percentage by 100, or a decimal by 100 to get a percentage, I divide by 100 to get my answer. Well, and that makes sense. 50 divided by 100. Well, there's sort of a placeholder decimal here. I move that over, right? And I get my 0.5 again. So we can really see how simple and circular that relationship is between 0.5 and 50. Now, this is a little harder. How do I get from 0.5 to 1/2? How do I get from 0.5 to 1/2? Well, let's take a detour. Let's figure out, and let's take a look at 0.5. Well, what does that mean? We know that just like with a number like, say, let's look at a little number like 157. I don't know, right? This is the ones digit. Pardon my writing. This is the ones digit. This is the tens digit, right? The tens. And this is the hundreds, right? So another way of writing this is 100 plus 50 plus 7, right? Same thing on the other side of the decimal. On the other side of the decimal, we can see that we have a similar placeholder system for keeping track of our digits. And in this case, right, this is the tenths, right? The tenths. Right. So instead of saying 0.5, I could say 5/10. And why is that useful, saying 5/10? Well, 5, there's 10, 5/10. So 0.5 as a fraction, it's really easy to express that by saying 5/10. And now this is a number that looks a lot more like my 1 over 2. And how do I get that to 1 over 2? Well, I look for a common factor. In this case, 5. 5 divided by 5 and 10 divided by 5, which gives us 1 over 2. So we can see how we went from that 50% to that 0.5 back to 1 over 2. And so that's really, you know, again, with a fairly simple fraction, we can really see this relationship between all of these quantities. So really important. Let's go over this again. So this is sort of our visual representation, right? This here is our ratio, right? This here is our fraction. This here is our decimal. And this here is our percent, right? Our percentage. Again, pardon my scrawl. Still getting used to my tablet. Okay, so this is great. And we've learned that if we have any one of these one things, we can find any one of the others, right? And actually, one little thing we talked about, how do I go from a fraction to a ratio? Again, if I have my fraction, I know that there's 2 total pieces. And that if I have one of those pieces, then my ratio is whatever's left. So in this case, if I have 2 pieces, I'm representing 1 with my fraction. Well, the other missing piece is 2 minus 1. So I know that there's 1 piece and 1 piece that we're sort of leaving out with a ratio of 1 to 1, shaded to dark. Okay, so now let's see if we can apply this to like a slightly more complicated situation. I don't know, something like maybe 2/5, 3/5. Let's start with 3/5. Oh, geez. Okay, so I'm going to have to divide this thing roughly into fifths. I don't know. Is that 5? Yeah, sure. Okay, so this is my kind of janky circle. We can sort of see there's 5 parts. Take my word for it. They're equal. We'll say they're equal. So once again, I'm going to shade. And in fact, when I shade, it'll look even nicer. Okay, there we go. I'm going to shade 3/5 of my circle. I'm going to shade 3/5 of my circle. So there's 2 parts here that are filled, and there's 3 that are unfilled, and 3 that are shaded in. So let's start once again with our ratio. So let's look at the ratio. Let's define a ratio as shaded to unshaded. So 3 parts are shaded, and 2 parts are unshaded. Okay, so far so good. Now let's, again, since we're interested in the shaded area, we're going to say, can we express the shaded area as a fraction of the circle? Well, of course we can. First thing I do is I think, how many total parts do I have? Well, my diagram looks kind of like not so great, so why don't I use this ratio, because it's easier to count. My ratio is telling me that there's 5 chunks to the circle that are all equal, and that 3 of those 5 chunks are shaded. So I'm going to start with the most important thing, which is 5 total chunks, and then I'm going to select 3 to represent these 3 out of 5 chunks that are shaded. Amazing, we're doing great, we've got our fraction. Now it's going to be a little harder to get our decimal. So let's think about what we got to do. So remember, I start here with my 5, because I take my denominator and move it here, and then I take my 3 and I put it here. And I want to think, how does 3 get divided into 5 equal parts? How does 3 get divided into 5 equal parts? And that's going to give me some information numerically about what this fraction or ratio represents. Well, let's take a look. 5 doesn't go into 3, so I got to grab a 0. And every time I do, I got to keep track of my decimal. Okay, well, I think 5 goes into 30 exactly 6 times. That's not so bad. So it looks like our 3 over 5 evaluates very nicely to 0.6. Okay, now let's keep going. We want a percentage. We want a percentage, so 0.6 times 100, right? We said that. So we move our decimal over twice, gives 60%. Amazing. Now let's work our way backwards just so we're comfortable with all sides of this, right? So 60, if I want to convert that, again, to go backwards, I divide by 100, right? So my decimal is here, boop, boop. That gives me my 0.6. I feel pretty good about that conversion. That's pretty easy. Now, again, this is the trickier part. How does 0.6 turn into 3 over 5? How does 0.6 turn into 3 over 5? Okay. Well, let's take a look. 0.6. Well, remember we said that this is the tens here. This is the first digit to the right of the decimal is the tens. So I have 6 tenths, should I say, or 6 out of 10. Right, and what's my common factor? This time it's 2. I can divide 6 by 2, and I can divide 10 by 2. I'll go this way just to show that we're getting closer to that number. 3 over 5. There we go. And once again, if I want to get from 3 over 5 back to my ratio, I know that I have a total of 5 chunks. And I know that 3 of those chunks are shaded. So the unshaded chunks must be my 5 initial chunks minus the 3 that are shaded gives me 2. So therefore, I know I have a ratio of shaded to unshaded of 3 to 2, which matches up with my picture. All right. So again, this really, really shows how we can go through this whole conversion between all of these quantities. Let's do one more. All right. So this is going to be an example where we have to kind of deal with one more digit, so to speak. So this time we're going to work with the fraction or ratio or percentage that is represented by 3/4 in this circle. So once again, I've shaded in 3/4 of my circle. So we'll start with our ratio. I see 3 of our 4 equal parts that are shaded, and I see 1 that isn't. Then for my fraction, again, I see there's a total of 1, 2, 3, 4 parts, or if I look at my ratio, if it's 3 to 1, that's a total of 4. And my fraction, as I'm looking at the shaded area, since 3 of those 4 areas are shaded, that's 3/4. Now I'm going to do my division. So remember, the bottom number goes to the outside of the division sign. The top number goes under the division sign. And I'm trying to look for 4 equal parts. 3 divided into 4 parts. So I find my 0 because 4 doesn't go into 3. I add my decimal. 7 times 4 is 28. So I'm not done. I need another 0. And 4 goes into 20 5 times, which means that 3 over 4, or 3 divided by 4, 4 divided by 3, should I say, is 0.75. That's our decimal. And again, to convert it to a fraction is quite easy. I multiply by 100 to get 75%. And it's easy to multiply by 100. We just move that decimal over by 2. Now again, if I want to work backwards for my percentage, I divide 75 by 100, and you can see that that decimal place would end up right back where it started. Now, going from 0.75 to 3/4 seems a little less intuitive. Like, I don't even see any 3s or 4s in this number. How can I really get that? Well, let's take a look like we always have, 0.75. Now, we have 2 digits to the right of the decimal, so it's a little trickier. So again, I know that this is my tenths column, pardon my spelling, and I know that this 5 here is my hundredths column. So again, if I were to look like a normal number like 75, right, we would say these are our 1s and these are our 10s, right? Now, it's a little trickier on the other side of the bracket. The first to the right of the bracket is our tenths, and then the next is our hundredths. So if we were to look at this number, I would say that I always, because I have 2 digits, we're dealing with hundredths, and I have 75 100ths, or 75 over 100. So that's how I was able to get from 0.75 to this fraction, right? So again, the answer, you can always think of it as whatever number you have to the right of the decimal, you take the power of 10, or the multiple of 10, power of 10, should I say, that is 1 digit larger. So if it was 0.7, that's 7/10, right? If it's 0.75, that's 75 100ths. You're adding 1 more digit or 1 more 0 to find that relationship, that fraction. So 75 over 100. Let's factor it to see if we can get to 3 over 4. I see 5 as a common factor. 100 divided by 5, I think that's 20, right? So I'll go this way just so we're getting closer to a number up there. 75 divided by 5 is 15. Okay, are we done? Not yet. Looks like we can factor by 5 again. 15 divided by 5 is 3, right? 20 divided by 5 is 4. And since 3 is prime, we can't go any further. And we found our number again. So there's another example, again, of all of these relationships. So, again, if we were dealing with like even a large number, right? Let's say I was dealing with, and this time I'm even going to use a calculator so we don't have to do all the math. Let's say I have some crazy fraction, like, I don't know, 87 out of 256. And I want to express that as a decimal. Well, I'm going to do the same thing, right? I'm going to go 256, 87. And again, if I didn't have a calculator, I'd go through all my long division, and I think this probably goes into it 3 times, I don't know. And I'm going to get some answer, right? Now, again, as a shortcut, I'm just going to grab a calculator, right? And so my calculator spit out a number that was 0.33, let's say 0.340, if I were to go to 3 significant digits. So I'm going to get a number that's like this, 0.340. That's what this crazy thing evaluated out to. Well, we can still do the same things, right? And in fact, yeah, so if I were to make it a percentage, well, what do? I multiply by 100. I move that decimal over, and I get 34%, right? And same thing, if I wanted to convert this 0.34 back to this bonkers fraction, well, what do? I don't have to worry about the 0 for a minute. I see 34 100ths. And that would give me an approximation of that fraction. So it's a little trickier when we have these fractions or that work out to numbers that are really long or fill up our calculator. But I just wanted to use some random numbers to show you that this conversion works both ways. Okay? So hopefully that'll help us out for some of the questions that have to do with transferring between all of these different terms and quantities.